Today, we're diving into a fundamental concept for high-performance Java applications, thread pools. If you're building anything concurrent, understanding this pattern is non-negotiable. Imagine every user request creating a brand new thread. This is incredibly inefficient. Each new thread requires allocating memory, CPU cycles for setup, and crucially, managing its lifecycle. And if you create too many, your operating system spends more time switching between them than doing actual work. This context switching is a major performance killer, exhausting CPU and memory, leading to application instability and crashes. The thread pool separates task submission from execution. When a client needs work done, it submits a task to an executor service. This service doesn't immediately create a thread. Instead, it places the task into an internal queue. Meanwhile, a fixed number of pre-initialized worker threads are waiting. As soon as a worker becomes free, it picks up a task from the queue, executes it, and then returns to the pool, ready for more work. This elegant producer-consumer model ensures that you reuse threads, control resource usage, and avoid the overhead of constant thread creation. In Java, the executor service interface is your gateway to thread pooling. It provides a higher-level abstraction, letting you focus on the what of your tasks rather than the how of thread management. You submit tasks, and the executor service handles thread creation, reuse, and shutdown behind the scenes. This powerful interface supports various pooling strategies, letting you pick the right one for your workload. Here's a basic Java example using executors.new fixed thread pool. We create a pool with 5 threads. Then, we submit 10 runnable tasks. Notice how we call execute. We don't directly create threads. The executor service manages the 5 worker threads, picking up tasks from the queue as they become available. Finally, shutdown initiates a graceful termination, allowing all submitted tasks to complete before the pool closes. Java's executors utility class provides several factory methods for common pool types. The fixed thread pool maintains a set number of threads, using a queue for excess tasks, making it ideal for stable, predictable workloads where you want to cap resource usage. In contrast, the cache thread pool creates new threads on demand and reclaims idle ones after 60 seconds. This is excellent for applications with many short-lived, bursty tasks, but beware. If tasks keep arriving faster than they complete, it can create a huge number of threads, potentially exhausting resources. While executors provides convenient factory methods for fine-grained control, you'll often directly instantiate a thread pool executor. This allows you to specify parameters like the core pool size, maximum pool size, and the thread keep alive time. More importantly, you can choose specific blocking queue implementations for task queuing and even define custom rejected execution handler strategies, dictating how to react when the pool is saturated, giving you full control over its behavior. Performance gains from using thread pools are significant. Depending on your workload, you can see anywhere from a 10-fold to a 100-fold improvement in task execution speed and application throughput compared to the naive approach of creating a new thread for every task. This efficiency is why thread pools are fundamental to high-performance concurrent Java applications. Thread pools are a cornerstone of efficient, scalable Java applications. They simplify concurrency, manage resources, and dramatically improve performance. Understanding them is crucial for any serious Java developer. What other Java concurrency topics would you like us to deep dive into? Let us know in the comments.